Hey students, this is lesson 524, or 525, shortcuts to multiplying binomials. A lot of you have probably developed your own little methods for multiplying binomials. This is just kind of making that official, and we're going to give names to those methods. So Michaela here, she noticed that one way you can multiply binomials is to multiply the first term in the first binomial by both of the terms in the second binomial. And then take the second term in the first binomial and multiply it by each of the two terms in the second. So there's 4 multiplications, which is normal. And so I'll just give you an example of how that works here. So we're going to take the first term times each of the terms in the second binomial. So we're going to do x squared. And then x times, it's actually a minus 4, so minus 4x. Then we're going to take the second term in the first binomial, multiplied by each of the terms in the second binomial. So we're going to do 3 times x. And then we're going to do 3 times minus 4, which gives us minus 12. Then we're just going to simplify. So we get x squared minus 1x minus 12. All right? Let's do one more example like that. I like to do number 5 here. So using Michaela's method, and I guess they call that the horizontal method. Some people do. You don't really need to know that, but so we're going to take this 2n times this 2n and this 2n times this minus 3. Then we're going to do this 3 times this 2n and then 3 times minus 3. So we get 2n times 2n is 4n squared. And then 2n times minus 3 is minus 6n. Then the red arrows, we're going to do 3 times 2n, both positive, so that makes 6n. Then we're going to do 3 times minus 3, which is minus 9. And when we combine like terms here, we have a minus 6n and a plus 6n. That makes 0n. So we end up with 4n squared minus 9. We actually get a binomial in that case. There's something about those two binomials that we started with that we ended up with a binomial when we multiply. And you might notice that as we do a couple more. All right. Now, Tamika, she approaches these equations a little bit different. And I've heard some of you say this in class. It's called the FOIL method, and I'll demonstrate what that is. By the way, on this problem back here, it asks, would you rewrite before multiplying? And I would say no, you don't really need to. You just need to make sure you multiply each of the items in the first binomial by each of the items in the second. And then you just combine like terms, so you really don't need to do that. But all right, so we're going to use this thing that Tamika uses called the FOIL method. And FOIL is actually an acronym for the words first, outside, inside, and last. And there's 4 multiplications, and each of those words represents one of the 4 multiplications. So I'm just going to write them down. First, outside, inside, last. I might use those again, so I'm just going to copy that. All right, so first means the first term from each of the binomials. So the x and the x. So that gives us x squared. The outside means the ones on the outer parts of the 2 binomials. That's this x and this 5. So, and they're both positive, so when we multiply those, we get plus 5x. Then inside means the inside 2 terms in those 2 binomials, which is the minus 2 and the x. So that gives us minus 2x. And then the last stands for the last term in each of those binomials. That's the minus 2 and the 5, and that gives us minus 10. Then we just combine the outside and the inside in this case, and we get x squared plus 3x minus 10. All right, let's try that on another one. So let's try this one right here, number 10, using the FOIL method. So we need to multiply the first 2. That would be the 3n and the 2n, and 3 times 2 is 6, n squared. And then outside would be the 2 and the minus 3, which makes 3n and the minus 3, which is minus 9n. Those are the outside two terms. Then inside would be the 2 and the 2n. 2 times 2n is 4n. And then the last two terms would be the 2 and the minus 3, which makes minus 6. And then I can just combine like terms. So I'm going to combine my minus 9 with my 4, and I get 6n squared minus 5n minus 6. All right, let's do a couple more problems here. Using our skills to solve a couple problems. Decide whether the equation is true for all values of x, for some, but not all values of x, or for no values of x. So I'm going to do the first couple with you, and then the rest I can do in class. Explain how you know your answer is correct. Well, in this first one, if we look at this expression in factored form, we want those two things multiplied to equal 0. And one thing you've probably discovered is the only way you can multiply numbers and get 0 is if one of the numbers is equal to 0. So if this expression, x minus 2, was equal to 0, then when we multiplied it by this, no matter what that is, the whole equation would equal 0. So just think about that for a second. Is there a number that we can subtract 2 from to get 0? And the answer is 2. If x is 2, then x minus 2 is 0, and then 0 times this would equal 0. So that's one answer. And we could also think about the same thing over here. If x minus 3 equals 0, then the product of those two would equal 0. So is there a number there? And the answer is yes. X could be 3. If x is 3, then x minus 3 equals 0. And when we multiply x minus 2 times that 0, we would get 0. So, and now you might be thinking, well, is there some other number that might work? Well, think about putting any other number in here. If you put 4 in there for x, would either of those equal 0? And the answer is no. And for any other number, 5, 6, whatever, they're never going to equal 0. The only time either of those expressions will equal 0 is if x is equal to 2 or x is equal to 3. So there's a limited number of solutions. There's actually 2 solutions. All right, the second one is this product of these two binomials, is there some value of x such that it's equal to x squared plus 5x plus 6? And it'd be easier to tell if they're both in the same form. This one right now is in factored form. This one's in expanded form. So let's expand the first one and just see what it looks like. So using whatever method you want, we can use the FOIL method. The first two, x times x is x squared. Okay, the outside, x times 2 is 2x. The inside 2, that'd be the 3 and the x, that makes 3x. And then the last two are 3 times 2, which is 6. So we get x squared plus 5x plus 6. And notice that is exactly the same as the other expression, which means no matter what number I put in for x, these two are going to equal each other. So it's true for all values of x. because both expressions really represent the same thing. All right, that's it for this lesson. The rest we'll do in class, and I'll see you tomorrow.